I
Did
have
you
it
not get
all.
mine yet?
Oh no, I didn't get it. You sent it?
She sent it like
Yes. I tried to.
I
Let
got
me
it.
see.
Hold on. Maybe I did. Hold on. Let me look. Crap.
Oh wait, maybe I sent it to Tyson.
Yeah, because I got it.
Oh,
I
you,
think I just pressed reply on the last one. Yeah.
cool. Well, then I can basically I'm just gonna randomize it, and then we'll get our 30.
Okay.
And then from there we'll just do like I'll just do the first 10, Tyson do the second 10, and then Alexis do the third 10. And that'll be our data. So we just look at April 1st and take the cheapest price. Doesn't matter the time, just cheapest price on April 1st, and then the cheapest price on July 1st. And that'll be the data that we'll use.
All right.
So
Are you guys wanting to meet again Wednesday just to get it all together to submit, or?
it'd probably be a good idea if we can meet on Wednesday, just to make sure we've got all the data and we put all the requirements, so he doesn't come back to us and say, "Here, do it again."
Yeah.
Are we not required to meet on Wednesday?
No, because this is the only thing we have this week. This and the test.
Oh, okay.
I'm fine with meeting.
Yeah, it'd be a good idea.
Yeah, I can meet whenever.
Maybe it's a good idea to meet for a little bit just to make sure we have everything. All right, Alexis, I just got it. So here, let me.
Okay, cool.
Oh, nice. There weren't as many S through Z's apparently.
Yeah, there was a lot of S's and T's, and that was pretty much it. So I think you got stuck with the big one.
Yeah, I was like, man, I felt like I was in A's forever. There were so many dang A's.
You'd think it would have been even, but or
Yeah.
close to it at least. But sorry about that.
No, it's fine. It's not a big deal at all.
I started doing it, and I was like, "There's got to be an easy way." So I started googling stuff and started clicking around. I got lucky, I guess.
Yeah, I probably should have done it, but I was like, I'm giving up. I can't copy all this. I'm just gonna screw it. I'm just gonna type them all. It was fine. I was watching baseball last night. I was good to go. All right. Okay, so when we finish the quiz, what I'll do is I'll just I'll put all this in the randomizer and get the 30 that we'll do, and I'll just email it out. I'll put it in alphabetical order, and I'll just do the first 10. I'll label it. I'll do the first 10, Tyson the second.
Okay.
Third 10. The quiz looks like it's like 39 questions today, so that may take a little bit. You want me to get started on it?
Yeah.
All right, let's do that. This daylight savings business is not the business. I'm not a fan of it.
This is my first time experiencing it. I'm from Arizona. We don't do it there.
Oh, yes.
I'm in Utah now.
Yeah, my sister used to live in
Weird.
California, so it was the same thing. I was always like, all right, are you on the same time as in California? So I was like, are you on the same time as us, or are you ahead of us now?
Yeah, it's weird.
Yeah. All right. Pull it up here. I was having a hard time with some of these hypothesis test ones to remember which one is which in the first couple questions.
Yeah, actually, I kind of started the quiz just to get an idea of it, and I was having the same thing. I always think those are easy, but then they throw me off.
Yeah. All right.
I'm ready.
Let's just start on the, I guess, second question this time. All right. So, article in the Journal of Small Business Management: Successful startup businesses in the United States and Korea compared one set of data compared educational level of people who manage successful startup companies in the United States and Korea. You want to determine if education levels managers, which hypothesis test would be most appropriate for this analysis? I feel like this is the chi-squared one.
Yeah, I put something different, but as you're reading it, I thought that too.
The only reason I was thinking is because it's gonna compare different educational levels. So high school, undergrad, master's, and doctoral.
For 2.
Yeah, in 2 different locations. So I felt like it was kind of similar to that one we had where it was like people who seek out chiropractic, is it the same in Australia or US or whatever it was?
Yeah.
I feel like this is the same type because it's got the different categories and it's different locations.
Yeah, I think you're right. I wasn't thinking about it like that, but
Quite
you're right.
honestly, though, I wasn't thinking about it the first time this way. The first time I read this, so I'm curious. What did you guys have also the first time?
I did 2 test proportions.
That's what I did too. But I think you're right because of the high school, undergraduate, master's.
Yeah, I think it's the chi-squared.
Yeah,
Okay.
because it's the chart, the thing,
Yeah.
So.
All right. Well, we can go with that, and if it's wrong, then we'll do 2 proportions. All right. So the second one, a human resources manager reported data from a recent involuntary reduction in force at her company. You're an attorney, want to determine if age discrimination was a factor. Company reported number of employees in 2 groups, 40 years older or younger and 40 years older. Also reported number of employees in each group were terminated. You want to determine if both age groups were treated equally. Which hypothesis test?
I put the test of 2 proportions on that one.
Yeah, I feel like this is the 2 proportional ones because we're taking the terminations of 2 different groups, the proportion of terminations for 2 different groups. Right?
Yeah, the only thing I think I get confused between the 2 proportions and the independent sample t-test.
Yeah.
How do you know when it's the independent one?
The independent one is dealing with like numbers. So trying to think well, for example, ours, the test we're doing is a paired samples t-test.
Yeah, because they depend on each other.
Right.
Okay.
If we did one, say what's one?
Where they weren't tied together.
Yeah, I'm trying to think of one of the examples that we had before.
Is it like if it's like men and women, it doesn't matter which, they're not related, but it's a man and a woman in each group, like that kind of thing?
Yeah, that idea. This one, I was thinking proportion because we're going to take the rate of termination among 2 different age groups or 2 different groups, which if we're taking a rate of something, it's like taking a proportion of something. Whereas I'm thinking say the cost of Nike sneakers versus the cost of Reebok sneakers. Those don't have an impact as far as why we select Nike versus Reebok, but we're comparing the prices of the 2. Right? Is that?
Yeah.
I don't know if I totally get it, but let's go with proportions for this one.
Okay.
The proportions are just.
I might just need to look into that. I'll go back and look into that better.
Yeah. So, just think of it. So, if we were to compare the prices, well, let's just do Coke and Pepsi. Do those rely on each? Do we have to rely on Pepsi to get something for Coke? I'm just trying to think this through. Would we need to have Pepsi to compare it against a number for Coke?
No.
So, in that case, they'd be independent samples, right?
Yeah.
Like if we were going to compare their prices. Like,
Yeah, I don't know. I mean, I get the difference between like the paired sample and the independent sample.
okay.
I get that. I just don't know when it's a t-test versus just two proportions.
Okay.
Proportions is
I don't know. I think I just need to go back and
Yeah. I think,
read
I mean,
that.
I think the way I guess I'm thinking about it is we'd use the t-test when we're trying to get, say, a fixed number like cost or time of something or something along those lines. I guess proportion is when we want to figure out how many of a group was.
Okay, that makes sense.
I think of it as numerical is the t-test and categorized is the proportions.
Yeah.
Okay.
So where they're categorizing 40 years and younger and 40 years and older, that's being categorized. That makes sense.
Yeah.
Yeah, I think I get it.
Like the next,
Thank you.
the next
Sorry.
That's all good.
gives numbers.
Oh, that's good. That was helpful.
Okay. Cool. So let's look at the next one. Now that being said, I could be completely off base, and you could be completely right. We'll find out.
No, the way that you worded it just now clicked. I think you're right.
Okay. All right. So a survey was conducted of a group of state lotteries. Random sample of 2406 adults were completed the survey. A total of 248 were classified as heavy players. Of those, 152 were male. We want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population, which is 48.5. Which hypothesis test would be most appropriate? Well, we know we're using one of the proportion ones because it tells us. I was thinking the one test of one proportion.
That makes sense. I got something else, but now that you read it, that makes sense.
Yeah.
Because if we think about the null and the alternative, the null hypothesis would be the proportion of males, which is 48.5. So we don't need to figure anything further about the proportion of males in the population, just in general, because it's given to us. So that's what we would use to compare our null to, or that's what we use our null to compare our proportion to. And we only have one proportion to deal with.
Yeah. That makes sense.
Yep.
Okay.
Cool. All right. So a student project compared the effectiveness of two different combination locks. One of the locks turned clockwise first, the other turned counterclockwise. They asked 25 students participate in the study. Each student was given the combination to each lock and asked locks. Time it took to open each lock was recorded. I want to determine if one of the locks is open, which hypothesis would be most appropriate. What did you guys do? What did you guys say with this one?
I think it's
This is one of the ones I was kind of going back and forth on.
I did independent sample t-test.
Okay. And what, Tyson, what did you do on this one here?
I put a sample or a paired sample, but well, I put in
So I get why it's a t-test and not a proportion now. I understand that. So now the question is whether the two depend on each other or not.
Yeah. So
I don't think they do.
yes.
Because the way that the way that they worded it is that the first group determines the second group.
Yeah.
They just are different. They don't. I mean, one turns clockwise, one turns counterclockwise.
Like, I think, it would be paired in my mind if we took one lock and we did it clockwise for one way and counterclockwise the other way.
Yeah, okay. That's kind of how I was thinking about it. So are you saying you think it's independent?
Yeah.
Okay. I think we're thinking about it the same way, at least.
Okay. Cool. All right. The next two questions. Okay, so a bank employs two appraisers. When approving borrowers for mortgages, it is imperative that the appraisers value the same types of properties consistently. To make sure this is the case, the bank evaluates 6 properties. Which confidence level would be used? All right.
So this one I did the paired samples.
I didn't get an answer for this. This is one I didn't get.
So I was thinking paired because there's two appraisers. Appraiser 1 gives his value for house 1, and then appraiser 2 gives his value for house 1. But maybe it's just I don't know.
Bank employs two appraisers. When approving borrowers for mortgages, it is imperative that the appraisers value the same properties, same types of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers recently valued.
So I guess it's the values that depend on each other. Like you have to, but maybe it's not. I don't know.
So it's the subjects. What do the subjects depend on each other for them to be paired? In this case, let's see. We're comparing the rates they do.
You'd get a different.
So this doesn't mean though that the appraisers are valuing the same properties. It just says to make sure this case the bank evaluates 6 properties that both appraisers. Oh, I guess yeah, it does.
You'd get a difference. So I think that's how it makes.
The bank evaluates 6 properties that both appraisers had recently valued.
So it's not the proportion one.
No.
And it's one of the pair. It's one of the either paired or independent because there's
It's either
two
paired or
different values, right?
Yep.
Okay.
So let's see here.
Um,
One subject determine the other. I don't think. Okay, so if I think about it like this, if say all 3 of us worked as appraisers, and he picked my work on a particular property, and say all of us wouldn't value the same property. Does he picking me lead naturally to he picking, say, Tyson? Like he could pick Tyson as equally as he could pick Alexis, right?
so I guess the question about whether it's paired is more about the group that's being sampled, not the values.
Right.
Because I'm thinking about it, like I get that, but I'm just thinking because the values for the two, I don't know, because they're evaluating the same 6 properties.
Mm-hmm.
So, I don't know.
I think where you'd get a difference, because I mean they'd obviously subtract one from the other to make sure they'll find a difference. I think that's what would make it a paired type deal, I guess.
So what are you thinking?
Well, I guess I'm thinking about the appraisers themselves. Like if we take the results of the first appraiser, does it matter which appraiser we select for the second one? I mean, say 6 appraisers go and they look at the same property. If we select one, does that determine who we would pick for the second one? I guess is the way I'm thinking about it. If it doesn't, then that would be independent in my mind.
Yeah.
I guess I think I'm thinking more about the properties than the appraisers. That's why I'm thinking paired.
Yeah.
Because the properties in group 2 do depend on the properties in group 1. Because they're comparing them, so they have to be the same.
Right.
I really don't know though.
I'm trying to think how this can be compared to, because ultimately when I'm thinking about these T confidence intervals, I'm thinking about the one that we're doing. So how does this compare if we're calling it paired? How does this compare to the project that we're doing?
Actually it is kind of similar in that, so group 1 we're going to have 30 destinations. Group 2 it's going to be the same 30 destinations.
Right. And we're going to just compare the prices of.
So it's kind of the same thing. It's 6 properties and then the same 6 properties, and we're comparing the value for them.
Yeah, that's right.
Right?
Okay. So we are comparing 2 different dates, which would be equivalent, say, to 2 different appraisers. And we're comparing.
Yeah, so the 2 appraisers are the 2 different days. That's like April 1st and July 1st.
Yeah. And we're comparing the rates on those 2 different days for the same destination.
Mm-hmm.
Which would be the same destination, would be the same property.
Yeah.
Okay.
That's it. Yeah, I don't know why this question is so weird, but I think that's it.
Yeah.
I think it's the 2 appraisers that makes it sound weird, but
well, I mean, if we're that by that logic, I mean they're comparing the same house. That'd be equivalent to our same destinations, and the 2 different appraisers would be equivalent to the 2 different dates we have.
Yeah, so if we know that we're correct in calling our test paired sample test, then I think that we can.
Yeah, and that's where I'm going. Man, I hope we didn't screw that up.
And he would have told us if that was wrong.
That's right. That's what I'm thinking. I'm like, man, he didn't just say, "Hey, you guys were using the wrong test."
Yeah, I think we're good.
All right. Okay. Well, good. I'm going with paired then on this one.
Yeah, me too.
And if it's wrong, then man, I really hope we got that our test is actually
right.
All right, cool. Let's do it. All right. So in a Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors reporting they were satisfied with their career path was reported. There's a lot of reporting in there. The same data was also reported for accounting majors. You decided to construct a 95% confidence interval to see if they observe difference in significant. If the difference is significant, which confidence interval is most appropriate?
So I did the confidence interval for 2 proportions.
That's what I did too.
Confidence interval for 2 proportions.
Because, like you said, so like percentage pretty much means proportion, right?
Mm-hmm. Yep.
And they're not related at all for the people that are being.
Or there's 2 majors is what makes me think that it's 2.
Say that again, Tyson.
Or there's 2 majors, so there's physiology and accounting.
Yeah.
I think that's what makes it 2 proportion.
Yeah, we're taking a percentage of satisfaction, which would be a proportion.
Yeah.
Yep. Okay, I'm good with that.
Cool.
All right. Stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decide you want to know if that is a true assertion by the company that makes them. Take a sample of 55 double stuffed cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true filling of double stuff in order to compare it to the filling amount in regular Oreos. Which confidence interval would be most appropriate for the study?
Would this be independent samples?
I thought it'd be because without the double stuff, you can't have the single stuff type deal. I mean,
So, which one do you think it was, Tyson? You kind of broke out right at the beginning.
I think it was the third because, I mean, you can't compare double stuffed Oreo filling to, say, Chips Ahoy or whatever because they don't have filling.
Yeah. Okay. So using friends, you take a sample. Measure the amount of filling.
I think it, in like thinking about our flights or the other one up there that was paired,
Mm-hmm.
I feel like it's just two different groups. Like they're not, even though they're both Oreos and one is double stuff, one is regular. I don't think, well, they don't depend on each other in the same way that like the appraisers do or the flights do, where they have to be like number one in each group is the same, number two in each group is the same. It's just a big group of things. Right?
Yeah, here's what's difficult for me. I feel like I'm almost leaning to one of the one sample ones. I'm almost leaning to a confidence level for one proportion because let me think about this. Hold on. That could be completely off base though.
Well,
the
not a
reason
proportion though, right?
Well, I guess it wouldn't.
We're just comparing.
It's tough for me because it says the only sample we're taking is 55 of the double stuffed Oreo cookies, and we're going to compare that against the null hypothesis, and the null hypothesis is going to be the filling amount in a regular Oreo.
Yeah, I guess that's true, but it doesn't say how we know the filling amount in the regular Oreo. So is that just a known thing?
Yeah, so I mean, the only data set that we're given in this question is the sample, the size of the sample that we're taking, and the amount of filling that we're measuring from a double stuff. So that I'm going more along the one sample T confidence interval.
What's the difference between the T and the Z again? I forgot.
Is Z when there's a known?
Oh yeah, it's standard Z.
Known mean.
Known
population mean.
Isn't it? Wait, one sample Z. Isn't that when we know the standard deviation?
Yeah.
Or yeah, yeah. Okay. Does the word compare, where it says in order to compare it to the filling amount in regular Oreos, does that like indicate that it is a paired or independent sample, or is that just, or could that be comparing it to like the known value? Do you get what I'm saying?
Yeah. The compare to me is saying that's the alternative hypothesis. Is it more? Is it less? Is it different than the known that we have?
So that's why you're leaning towards the one sample.
Yeah, because I'm thinking, I would think that based on this information, I would think that the hypothesis, the null hypothesis, is the true mean filling or the mean filling for just a regular Oreo. And so we're trying to figure, we're going to compare how much filling there is in a double stuff versus a regular.
So if it were a paired or independent sample, they would have to indicate that we would also test the amount of filling in regular Oreos. Right?
Right. Yeah.
That was a sentence in this problem. If it said, and then you take a sample of 55 regular Oreos, then that would make it.
Yeah, because then at that point, our hypothesis would be, our null hypothesis would be the null equals 0 because they'd be the same.
Yeah. Okay. So if it's one sample, is it Z or T?
It would be T because we don't know the standard deviation of this.
Yeah.
Okay. Okay, I'm good with that. And hopefully we're on the right track with all of
Yeah,
these.
I'm. See, this is where I like these ones. I'm like super mixed about. I'm not like 100% confident in any of these. That's why I'm like, ugh. God.
So it'll be good to
Which
see
more correct?
which ones we get right. So
Yeah. What was that, Tyson?
It's like which one's more correct out of them all.
Yeah, and it's just like trying to sort through to make sure it's falling into the categories of how each one of these is set up.
yeah.
All right. Well, let's go. Let's see what happens. All right. Which one of the following best defines the notion of the significance level of hypothesis test? So this is the probability of committing a type 1 error.
Yeah.
Yeah.
All right. Following best defines the notion of the p-value of a hypothesis test. It's the probability of observing a sample statistic more extreme.
Yeah.
Okay. Suppose you create a 95% confidence interval for a mean. You've been told reporting this by saying something like we're 95% confident that the true mean is between 10 and 20. What exactly does this mean? For these ones, I always think about the percentage of percentage.
Yeah.
95% of all 95% confidence intervals actually contain a true mean. I feel like we've had this question on a couple different like quizzes and tests.
Yeah, we definitely have.
All right, so you take a simple random sample of 100 adults from a town in the western United States to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion, the percentage of people in town who invest in the stock market is 0.3. So what is the mean of the distribution of the sample proportions? That'll be 0.3.
Right. Okay.
Yeah. We all go with 0.3?
Yeah.
Okay. So what's the standard deviation of the distribution of the sample proportions?
I got 0.046.
Yeah.
Can you remind me how you get that? I was blanking on that.
Yep. You're going to take the 0.3, the average, the sample mean. This is the p times 1 minus p over the sample size, and you take the square root of that.
Yep.
Square root of the whole thing, or just the sample size?
The square root of the whole thing.
Okay, I remember that now. What number did you say you got?
I got 0.046.
Oh, 4, 6. Okay.
Tyson, did you get the same thing?
Yeah, I got the same.
Okay. All right, and then what's the probability that your sample of 100 adults will have a sample proportion less than 0.25?
I got 0.8. I don't remember.
Yeah, this one's going to be the value minus the mean. So 0.25. Hold on, let me go back to it. So this is going to be 0.25 minus the mean, so 0.3 divided by the standard deviation.
Yeah.
And that gives us, hold on, let me make sure. That gives us the z-score, which we plug into the applet, right?
Yeah. Less than.
0.25 minus 0.3 divided by.
And then it's the left tail, right?
Left tail, correct.
So I got 0.136.
Yeah, I got 0.13. Well, I got 0.138.
Oh.
What was your z-score?
Well, negative 1.091. Divided by, hold on, I'm redoing it right now. Just double check. Yeah, negative 1.091. Or yeah.
So say how you got that again?
So Alexis, now let me ask you, Alexis, did you round your did you use the rounded standard deviation number?
Yes, that's what.
I think that's what would do it.
Yeah.
So Tyson, the way I went about it here is I took the value that we're trying to figure out, so 0.25,
Yeah.
and then subtracted the population mean or the distribution mean,
Yeah.
so 0.3, and then divide that by the
Standard
deviation, but actually working out the formula.
So what'd you get for the z-score?
I had negative 1.091.
Oh, okay. I did it, and that's what I got second time. Did it right.
You got it? Okay.
Then for the 138, is that what you said you got?
0.1, yeah, 0.138.
What'd you get for z-score again? Sorry.
The z-score I got is negative 1.091.
Okay,
I like the review better. The review actually gives you multiple choice.
Then it is so less than, so you get 0.138, right?
Should just say anything.
0.138, yeah.
All right, that's right.
She was looking at me, and I'm like, oh.
We're good on that one, Tyson?
Yep.
Okay. All right, so this one, Acupril, clinical trials, divide two groups. So this one's going to be a proportion one. And we have two different groups. And we're comparing the proportions for the two different groups. So this one is just straight, what's it called? The Excel document.
Yeah, plug it into the Excel.
Yeah.
Is it the two proportions one?
Yeah.
Yeah, the two proportions one. Okay. Hey.
What did you use for numbers?
What did it say again?
What did you use for numbers?
For the numbers?
Yeah.
So group one, I had the X as 61.
Okay.
And then the N, which is the total of 1563.
All right.
And then X2 15, and a total of 579.
All right, that's right. I got a confidence interval of negative 0.003 and 0.029.
Yeah, I got the same thing.
Ooh.
All right. Did you get the same thing, Alexis?
All right, can you tell me what you got one more time?
Yeah, I got negative 0.003 on the lower and 0.029 on the upper.
Okay.
Hey. Gosh, you stupid. Go on. Go on. Go. All right. So margin of error.
It's 0.018.
What'd you get?
0.018.
Okay, so I got 0.016. How'd you get 0.018?
Oh, I did my phone. Sorry.
Yeah, because I just remember what I got. Basically, I just subtracted the lower bound from the upper bound and divided by 2. I just remember that on one of the quizzes that we were doing, we couldn't do that. We actually had to work it out. I don't think that was this particular.
So okay, so I did. Okay, so the total difference between so 0.016.
Uh-huh.
That is the sorry, okay, that is the difference between the two divided by 2, right?
Correct.
But because one is negative, don't you have to, so you would take like 0.029 and subtract 0.016 to get the middle value? No, that's the point estimate, huh?
Yeah, that's the point estimator one we're working on for.
Okay.
So
too much.
the point estimator of this one is what, 0.013? If it asks us that?
Okay. Okay, so 0.016.
6.
Yeah. All right, so lower bound 0.03, upper bound 9. Okay. All right. To perform a hypothesis test, see if the experimental groups businesses is different than the population. Use a 0.05. So our null is equal to, and our hypothesis is different. So not equal to.
Yeah, that's what I.
Yeah.
So the top one.
Yep.
Mm-hmm.
Okay. All right.
I got a test statistic of 1.458.
Yeah.
1.458.
Yeah.
Same. And then
And p-value of
Say it again.
0.928.
No, I got 0.145. Did you change the type of test?
Nope. That's why. 0.145. Okay.
And is there sufficient evidence? No.
No.
No, I failed to reject the null.
Failed to reject.
Yeah.
All right. So this one's the chi-squared one that we're using for the next one. So again, this is just all straight Excel. And when you got it, I've got it here.
I'm just. All right.
This is the one that worries me about this question, because on the review, the answer is different than what I have in the Excel doc in terms of how it rounded it. So I got a test statistic of 0.6579.
That's what I got.
I'm gonna go with that, but like if you the review has the answer is 6.580. So that's what worries me a little bit. But I'm using the Excel doc as we're supposed to. So
Yeah.
hopefully they've got it right.
You said 6.579.
Yeah.
There's no any other way to do this, right? So
Yeah. That's to be the
you
only
don't really
thing
have
to
to
go
find.
off of.
Okay.
And the p-value I got at 0.08 or yeah, 0.087.
Yep.
And then I'm going to we're not going to reject the null because it's greater than 0.05.
Yep.
All right, we go with that?
Yeah, that's what I got.
Yeah.
Okay. So we have insufficient evidence to say. We have insufficient
Morning
evidence.
evening person is not independent of age. The last one, right?
Yeah, that's what I got.
Okay.
All right. So a recent book noted that only 20% of all investment managers outperform Dow Jones. A random sample of 200 investment managers had graduated from the top 10 business programs over a 5-year period. 50 outperformed the Dow Jones. Let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed Dow. All right, so based on the built sample, created 95% confidence interval. So this is one proportion. So I got lower bound at 0.190 and upper bound I got at 0.310.
Okay, so the sample size is 200. The X value is 50.
Correct. And then the null hypothesis is 0.2.
And did you get 0.190 for the lower bound?
Lower bound 0.190, yeah.
Right.
And then 0.310 on the upper bound. We gotta go with that.
Yeah, that's
Yeah.
what this
Okay.
is what I struggled with.
Yeah, so this one is going to be, this is where you take the, so to find the margin error, you take the percentage, that z-score for the percentage, or sorry, yeah, for the level of significance. So this is the 1.96. And then multiply that by the standard deviation. And that gives you your margin of error. But that's actually, I'm sorry, we're not looking for margin of error. We're looking for number. So number is the z-score. So this is 1.96 divided by the margin of error, which is 0.02, and then square that number.
What's the margin of error?
0.02. And then after you square it, multiply it by the mean sample and mean distribution. Hold on. Where is it? 0.2. And so it's 0.2 times 1 minus 0.2, so 0.8. So I have 1536.64, but you can't have a fraction of a sample, so you round up.
You got 15. Oh, yeah, I did.
15, so I got 1537. Are we on the same page with that one?
Yep.
Oh, I'm losing light here. There we go.
1537.
Yeah, 1537.
Okay.
All right. So suppose you wish to see if there's evidence that graduates of one of the top 10 business programs that performs better than other investment managers. So the null is 0.2, and we're trying to figure out better, so greater than 0.2.
Yeah. So it's like from the bottom.
And then the requirements, that's the NP is greater to or equal to 10, and then N times 1 minus P greater to or equal to 10. Go. And then 31, what's the value of your test statistic? I've got 1.768.
Yeah.
P value, I got 0.039. And is there sufficient evidence? Yes, since it's greater than 0.05, so yes, I rejected them all.
Yes.
All right, so 34. Computer software is commonly used to translate text from one language to the other. As part of this PhD thesis, Philip Cohen developed a phrase-based translation program called Pharo. This is the one we had before. A BLEU score is a number ranging from 0 to 1 that indicates how well computer translation matches a professional human translation of the same text. Higher scores indicate a better match. BLEU helps companies who develop translation software to monitor the effect of daily changes. So to compare Pharo's ability to translate with similar computer translation software, Cohen took a random sample of 100 blocks of Spanish text, each of which contained 300 sentences. Used Pharo to translate each of those to English. BLEU scores calculated for each of the 100 blocks. Scores are recorded in data there. So he wants to use this data to see if his mean BLEU scores differ from the BLEU score of another leading translation software, which has a population mean of 0.295. All right. So which test are we using for this one?
It'd be a sample t-test.
Sample t-test. Yeah, because we don't have a standard deviation, so it'll be a t-test. We're only given data from one.
Say that again, sorry.
We're only given data from one set of data. Sorry, we're only given one set of data.
Yeah.
When we're comparing against a null, the null would be 0.295. Is that right? Am I thinking about this right?
Yeah.
Wait, hold on.
Would it-
Alexis, what do you think on this one? What test are we using? Uh-oh. Did we lose her? I think we lost her. She'll come back. So, are you thinking one sample here, Tyson? Or you think?
Well, it only gives one set of data, doesn't it?
Yeah.
That should mean it's one sample, right?
Yeah.
What'd you get for the reward?
I'm still putting it in right now. Our blocks. Shows it was similar. I took a sample of 100 blocks. This was reported. No. All right. So I have. Man, I feel like this is wrong. So the lower bound I've got at 0.282.
That's what I got. Then an upper bound of 0.293.
Yep. Calculate the degrees of freedom. The test statistics. The degrees of freedom is 99.
Yep. One second, I'm going to write all this down because I did not get this one very long.
Test statistic. I have negative 2.803 for the test statistic.
I lost you.
That's okay.
What number are you on?
We were just running through this one, the sequence of questions for this one. So we're on 37.
Okay. I'll just catch up, and then if you don't mind, if I just check my answers in a minute.
Yeah, that's fine. We were thinking one sample t-test for this one.
That's when I froze, is when I tried to open up the Excel for that.
Okay.
Okay.
What'd you get for a test statistic?
I got negative 2.803.
Okay.
You get the same thing?
Yeah, I did.
Okay.
P-value.
P-value. Hold on.
6.
Want to see if his mean blue scores differ from the mean blue score of another leading translation.
So I'd mean
Not equal to?
Yeah, that's what I thought. I thought that's what different meant.
Yeah, so I got 0.006 for that.
Yeah, that's what I got too. I wish I could just take the test after doing this.
Right? Doesn't even open until tomorrow.
No.
All right, based on the results of the test, what would you conclude? That we have sufficient evidence to say the true mean is different than 0.295. You want to pause there for Alexis to catch up? Then we can check their answer.
Yeah.
I just want to make sure I put everything in right. So for the lower bound, 34, did you get 0.282?
34, 282, yeah.
And then 0.293. 35.
Yep.
Okay. And then degrees of freedom is, I did not put that in. How many is it? Is it 99?
Yep.
Okay.
And then
Test statistic, negative 2.803.
yep.
Okay. And then p-value is 0.006.
Yep.
Then we're gonna project the null. We have sufficient evidence to say that the true mean is different than 0.295.
Yep.
Okay.
Okay.
Are you on 40 then?
Yep. Alrighty. Okay, so study was done to test the notion that people are taller when they first wake up in the morning and in the evening right before they go to bed. Test this theory, the heights of children in boarding school and they're measured. But just the premise of this just seems odd. Like
Yeah.
Yeah.
shrink during the day, seriously? Values were recorded in millimeters for each child. That is recorded. So this is a paired sample one here. These are the ones that make sense to me that it's paired sample. Like cut and dry, no question about it. All right. And then taller in the morning and in the evening to find everything AM minus PM. All right, check 95% confidence interval. Okay. So I've got lower bound here at 8.728.
Yeah, that's what I mean.
So is the type of test, is it greater than?
I just think it's not equal to.
Wouldn't it be?
Even though it says to determine if children are taller in the morning than in the evening?
Yeah, I put greater than.
Oh yeah, you want to? Yeah, that's right. Yeah, I'm sorry. You want to determine the children are taller in the morning than in the evening. The greater than or less than?
That's what I was trying to.
Because our null is the morning, or no, sorry, our null is even 0.
And then the AM height is the first variable.
Right. So it's going to be variable 2 is less than variable 1. Which would be a less than test.
So
Should be different.
Hey, I have to pause real fast and grab my child. Hold on 1 second. Well, just continue. I'll catch up.
You're fine.
do you think that it's greater than or less than?
That they're great taller in the morning, right?
It depends on. Which variable depends on which? Like, if it's asking is variable 1 greater than variable 2.
I thought it was greater than personally, but
Well, did you get for your confidence interval 8.728?
Yeah, I did.
Just do that and then we'll figure out the other part. Test statistic 22.446.
446. Yeah, that's what I got.
Okay.
Degrees of freedom is 40.
40. Oh no, it's 40. There's 40. Okay. 40.
This is where we got to figure out if it's greater than or less than.
Yeah. I'm thinking it's greater than. The differences are all really high. And if you change the greater than to less than, then the p-value is 1, which would mean we would fail to reject, so I think we should reject.
Yeah. Well,
right?
it was greater than when I read it too.
All right.
Yeah, I think it's
Did we
greater
decide
than.
on? Did we decide on greater than or less than?
I think it's
We did the other problems, but the p-value is what's affected whether it's greater than or less than.
Right.
I think it's greater than.
Yeah, greater than makes more sense when you look at actually the values.
Yeah, that's what I was just saying. Is the differences are all high, and so the p-value should be lower
Yeah.
because it's 1 if you put less than. So.
Yep. So just to double check, up lower bound I had 8.728.
Yep.
And then upper bound 10 point. That's all checked up. Heck. 10 point, is it 10.455?
Yep.
Yeah.
Dang, my thing's all jacked up. Sorry. 8.728. All right. Test statistic 22.446.
Yep.
And then degrees of freedom 40.
Yep.
The degrees of freedom.
Yeah.
Yep.
Yeah.
And the p-value, well, 0.000.
Uh-huh.
What'd you get for the p-value?
0.000. Well,
I got 1.39.
I mean, it's 1.39 or 1.4 or 1.40 times 10 to the negative 24th.
Yeah, so that would be yeah, it's really, really, really small.
Really small.
Wait, so what'd you get for the p-value?
1.39734 times 10 to the negative 24th.
Oh yeah. So is that 0?
Yeah.
There's 24 zeros before any of that 139.
Yeah.
I don't know that.
All right, and then based on the results of your test, is there enough evidence to suggest the children are taller in the morning than eating? Yes, because we rejected the null.
Yes.
Cool. Are y'all good with everything?
Yeah, I kind of just want to see if we were right on those
Yeah. I
first
guess
two.
those are the big questions there.
Yeah.
All right, well, let's go submit it and see what happens.
We missed 5.
5.
5? I've got 1.
Oh no.
What did you get? What did you guys put?
Let me see.
I've got a 42 out of 43.
Yeah, I missed one too.
What did you guys put for question 5?
Where-
Question 5.
Oh,
That's not.
you put paired. Did you put paired sample test? Hello. Hello.
Hey,
hold on, just a sec.
Did you guys put a paired sample test for that?
for number 5, I put independent.
I put independent too, and it says I got it wrong.
Yeah, I got it wrong also.
Oh, so do you guys think it is?
That's the one we got wrong.
Yeah, wait, Tyson, did you get more wrong than that though?
Oh no.
Okay.
I haven't. No, I'm in.
Oh, were you saying that you missed number 5?
Yeah, I'm in this one.
Oh, I was we got
I
5
thought you were
wrong.
saying you missed 5.
Oh no, I'm in this number 5.
That's funny. Okay.
Sorry.
Student project. Okay. One of the last. One of the last turn clockwise, the other turn counterclockwise. Yes. Combination lock has to open. Time it took to open the lock recorded.
Okay, so it's not a proportion.
Well, that would be the only thing is actually I think it would be a proportion
It would be?
Is it
because we're measuring time.
But
Because the only other one would be paired samples.
but how would it be a proportion though? Because we're just measuring time.
That's a good question.
What is the ANOVA one again?
That's me.
ANOVA is
I don't remember.
that's the one when you have like you have multiple samples. Like you run into like 6 samples or 6 subjects. Basically, you have more than 2 subjects that you're trying to compare.
So it's not that for sure, right?
Yeah, it's not that.
Yeah, it wouldn't be that one.
Okay.
Yeah,
Gotta be a key proportion or a paired two sample.
well, we're dealing with more than one sample, so it's got to be one of the 2 sample ones.
So it has to be paired, right?
Yeah, it's got to be.
But
Well, I guess if we think about it like this, though, well, our logic when we got to the adjuster one was right. So if we're taking the adjuster logic we had, then the house would be the students, and the type of locks would be the different adjusters.
I think that's weird, but I think that's right. Because the locks are the same for everybody in both groups. Yeah.
And we're measuring a difference between 2 different metrics of the same person who's doing it. So since the subject is the same, we're just using a different metric or a different test to study their results. Because the subject is the same, it makes it paired.
So comparing it to our flight test, the counterclockwise and the clockwise is like April 1st and July 1st.
Right.
Right?
Correct. And the student is the destination.
We're comparing times and prices.
Yeah.
Okay. Makes sense then.
Now the question is, do I want to go all the way back
I
through
know.
this all over again for one weight?
I think I'm going to because I have like a 90% exactly in the class.
Yeah.
So I'm going to try really hard this week to bring that up to a little safer number.
Yep.
So,
Cool.
but yeah, no, this was really good though. I feel better about the exam.
Yeah. I think, remember on the last one, the last test we took, they threw in stuff from the other units also
Yeah,
that wasn't on the review. So it may be a good idea just to take a look through the reviews from the previous units too,
yeah.
just so we're not caught off guard with it.
hmm
As far as when we finish here, I'll go ahead and I'll do the I'll randomize the all the data we got for the destinations, and I'll email that. Give me maybe like 5-10 minutes,
All right.
and I'll email that out, and then just I'll label it also for who's going to do what. Do we have any questions though about what we're grabbing for the data when we do the destinations? We all know what we're doing, right?
Should we specify like I was saying, I keep overthinking it. But only doing like one way or nonstop flights or something like that, just to keep it standard.
We can. I mean, we identified that also in our proposal. That
We did?
that we were using nonstop flights, or sorry,
Oh,
that
okay, good.
that we're using one-way flights at the cheapest cost. That I don't think we didn't specify that we were using nonstop flights, because I think a lot of these places you can't go nonstop to.
That's true. Okay, then that actually, I guess if we're getting the cheapest one, then
Yeah.
okay.
Because ultimately, Delta is going to be servicing this. They're not going to take you Delta to United on a Delta.
Yeah.
So then on the Excel doc, when we do it, why don't we just do your destination city that you're using, and then in one column do the April 1st price, and the second column just do the July 1st price.
Okay.
And then compile them. I mean, if you want to send them all to me again, I could put it into one document. And then I guess we could just meet again on Wednesday at same time, and that way we can just make sure everything's put together for this part of the project.
Okay.
Sounds good.
Sounds good.
Cool. All right. Well, then I'll send that out to you guys in a little bit, and we'll meet again on Wednesday.
Okay. Thank you.
Okay. See you guys.
Bye.